in semiconductor, we acknowledge the importance of semiconductor industry in Malaysia, the growth right now. So having said that, once we also develop or have, establish the facilities for some other technologies, as what I mentioned earlier, that characterization testing instruments that we use for that particular technology can somehow also be used for semiconductors. I give you an example. We have here in our green plastic technology, they have what we call a contact angle tensiometry instrument. Contact angle tensiometry instrument. Also, apart from performing analysis for plastics, it can also be used for some part of electronics. Yeah. All right. So that for us, maybe we can use that for supporting some requirements. If there is a requirements from semiconductors industry for measurement of certain like cleanliness of the IC integrated circuits or chips or something like that. Yeah. So we also have instrument, for example, FTIR, Fourier transform infrared spectroscopy, that might be useful also for some semicons for detecting or add certain elements. All right. And also we have some instruments as well in the green plastic technologies such as TGA and also DSC for measurement of thermal analysis that might be useful for semicon industry.
In semiconductor, silicon is one of the superior material that are reigning the age of AI right now. But everybody globally, they are moving towards the more smaller chip, more advanced high performance chip that requires the new material. And then the choice of material right now, what I can say is some sort of gallium nitride, the carbon nanomaterial based material. So MREC can support on the know-how to provide the knowledge to industry towards of course, because the technological nodes in semiconductor right now towards the 2 to 3 nanometers. TSMC is running towards that thing right now. So we in Malaysia, we can provide some sort of material characterization, material analysis, material scrutinizations toward that thing, toward the technological, toward the fabrication of higher technological nodes for chip making.
Why the characterization is important? Because it is very, very critical for semiconductor industries to ensure that the product is at high yield and then free from contaminants, particles, dust, and so on, that can actually affect the performance. Characterizations here is somehow important to ensure that, for example, there are certain products of semicons might fail due to contaminants, right? So characterizations helps to determine where the contaminants come from. Is it coming from the processes, or is it coming from the materials itself, or is it coming from the warehouse or something, or raw materials that are coming from the warehouse? So these are the things characterization play the role in semiconductors.
X-ray photoelectron spectroscopy, namely XPS, is a very advanced materials analysis. You can go deep toward all the functional, all the very the minute data and informations of the material you can capture through XPS. So it is very important. And then in Raman, we can have some sort of thermal based analysis, material identifications, and then because in semiconductor, what important is you have a silicon material, but silicon is neutral. You need to add something, some sort of other elements like gallium, like what they call the dopant. generally name is dopant. So the dopant will act so that the material, the semiconducting function can go. So in terms of how to detailed analysis on the dopant, usually dopant is around 0.5, less than 0.5% of the overall material in semiconductor. So we must have the high advanced analysis like this, some sort of Raman spectroscope. Raman actually can complement infrared. Infrared can go all that thing, but Raman can select all the hidden data from the semiconducting material. So it is important. Of course, the XPS also can provide some sort of analysis. Both of this device is on the material identification, material characterization. The government have a new strategy in national semiconductor strategy, which make a great opportunity to us. And then in terms of competitive advantage in this area of material analysis, we do have we do have some sort of learning curve on what material fit for LED, what material fit for IC, what material fits for solar panel. Solar panel also in terms of semiconductor material products actually. So the quantum dots we can provide that some sort of know-how to industry.